حاضر.
عبد الرحمن عبد الله
موجود.
بشار
حاضر يا دكتور.
إحسان.
I'm here, doctor.
All right, so last time we started the convolution for continuous time signals. Okay. And we solved a problem also, if you recall. Okay, this was the problem that we solved, okay, and this was the answer. Okay. Yeah, someone's mic is on. I think it's
Hello, doctor.
yes. Go ahead.
Saleh. I was
Yeah, after the class.
having problem in the link. Okay.
Okay, so today we are going to do some more problems in continuous time convolution. Okay, so let's first do this problem number 15. Okay, so let me bring up the screen for you. Okay, so first of all, the problem that is given in the slide is x of t is given as e to the power minus 2t u of t. Okay, and y of t is given as e to the power 3t. Okay. And what is the question? The question is find the convolution of the above two signals. Okay, now so far what we have been doing is that we have been finding the convolution of x of t and h of t, where x of t is the input signal and h of t is the impulse response. And when we find the convolution, we say that this is equal to y of t. Okay. In this problem, he gave us x and he gave us y, and he's asking for us to find the convolution of the two. So you should not get confused with the symbols. Okay, it doesn't matter. What I mean by that is that what he's asking is x of t convolution with y of t. That's it. Now, in previous problems, y has been h, so that's okay. This time it is y. It could be any other. It could be any other letter.
Doctor,
Yeah, go ahead.
it could will be y of t convolution of h of t and find x of t.
No, no, no. Just I'll explain. Just 1 minute.
Okay.
No, no. This is not what I'm saying. What I'm saying is that you could be given anything. For example, if someone gives you a of t and b of t, and he says find the convolution, you just convolve them, right? Uh, until last week we used to have this. You have x of t and you have h of t. So you used to convolve them. Today we have x of t and y of t. So okay, we will convolve it. Just treat these two signals as any two signals. The letter could be anything: x, y, z, w, anything. Okay. So when he says find the convolution, you just take those two signals and use the formula and find the convolution. Right? Is that clear?
Yes, yes.
Okay. So basically the purpose of this explanation is that uh, don't expect that every time the convolution will be between x and h. It could be between x and y, it could be between x and z, it could be anything. All right. So now let's first write the formula. The formula is the convolution of x with y is given by integral minus infinity to plus infinity x of tau into y of t minus tau. Remember, it used to be h of t minus tau, but since in place of h we have y, so we say y of t minus tau. Then we substitute here the value, so we know that x of t is given as e to the power minus 2t u of t. Okay, the formula wants x of tau, so I'll just change all the t's to tau, e to the power minus 2 tau u of tau. Then the question needs y of t minus tau. So since y of t is given, so I write here first y of t, which is e to the power 3t. So that means y of t minus tau will be equal to e to the power, yes, help me, what should I write here? E to the power,
Minus tau.
no, y minus tau. I have y of t and I need y of t minus tau.
Minus tau.
Anybody else?
3. Uh, 3t minus tau. Or not like this.
Yes, yes. But there is a catch here. Many times the students write it like this: 3. Is this correct?
I think no.
No. Why?
Because 3 will multiply by tau. Now here is cannot multiply by tau.
Yes. So what should I do to correct it?
Make a brackets.
Yes, exactly. So it should be like this. All right. So now we have x of tau, we have y of t minus tau, we substitute in the formula. So this becomes, let's call this integral, let's call it z of t. Okay, after convolution the new one is z of t minus infinity to plus infinity, x of tau is e to the power minus 2 t tau u of tau, and y of t minus tau is e to the power 3 t minus tau dt. Okay, is this clear? If there is any question, ask me now.
Why you don't change the limit of integration?
Yeah, we will change the limits in the next
Oh,
step. Yes.
okay, okay.
All right, so there is no question, so let's move. Now we change the limits. Okay, so very carefully, first of all, tell me what should be the lower limit. What should
I
be
think 0
zero, right?
because we have unit.
Yes, because of this guy, the lower limit will be zero, right? Because if tau is less than zero, then this u of tau will be zero. So that's why it is supposed to be start from zero. Okay. All right. Now what should be the upper limit?
Tau
Why tau?
because we are working with it.
No, this is not the reason.
Bec- um,
What should be the upper limit? Remember, in the previous questions, how were we deciding the upper limit? Using what? We used to have here u of t minus tau. Remember? Let me show it to you so that
It's T, right, doctor? Because we are working with the time.
do we remember this? See, how did we decide last time the limit, the upper limit? We decided the upper limit last time because we had a u of t minus tau, and we knew that when tau becomes more than t, okay, this u of t minus tau becomes zero, right? Because t minus tau becomes negative, so u of t minus tau becomes negative. So that's why we did not let tau go beyond t, so it was t. Now in this case, in our problem, okay, you can see that here there is no u of t minus tau. So that means there is no limit on the upper value. I mean, I can have infinity here,
Infinity.
right?
Yes.
Because there is no limit. There is no u, so nobody is restricting you, right? So then it becomes e to the power minus 2 tau e to the power 3 t minus tau d tau, right? Any questions until now? All right, then this is equal to 0 to infinity e to the power minus 2 tau. Now I have to break it because I can see that there is a t which is a constant for this because the variable of integration is tau, and t does not depend upon tau, so it's a constant, so we'll have to take it out, so that's why we need to open it. Okay, and this is equal to t equals 0 to infinity e to the power minus 5 tau e to the power 3 t d tau. Okay. Then since this guy e to the power 3t, he does not depend upon tau, so I can move it outside the integral sign, right?
Yes.
Yes.
So this is equal to e to the power 3t integral 0 to infinity e to the power minus 5 tau d tau. Okay. You know what I will do? I will send you this. This what I'm writing here. This is on Microsoft OneNote. I will make a PDF file and I'll upload it on Blackboard. Okay. Because I cannot record the lecture, but at least this work can be saved. All right.
Okay.
Now what should I do? What should be the next? E to the power 3t is a constant, so it is outside. What should I do with
Integration.
this integration? Exactly. So what is the integral of this guy?
It's the same divide by minus 5.
Exactly.
Yes.
Exactly. Yes. So this is equal to divide by e to the power minus 5 tau divided by the differential of minus 5 tau, which is minus 5, and the limits are 0 to infinity, right? This is equal to e to the power 3t is a constant. Inside, what we can have is, first we put the upper limit, so it is e to the power minus infinity, minus, then we put the lower limit, so e to the power 0, okay, divided by minus 5. Okay. And then this is equal to e to the power 3t divided by minus 5. What is e to the power minus infinity?
This is 0.
0. We have done it many times, right?
Yes, 1 over e of infinity.
Exactly, exactly. So because if anybody, does not recall, then remember we did this. E to the power minus infinity is equal to 1 over e to the power infinity is equal to 1 over infinity is equal to 0. That's why this quantity is 0. Minus e to the power 0 is 1, right? And then this is equal to e to the power 3t divided by 5, and then I have to put a u of t to tell that this is only for positive values of t. All right, is it clear? Any questions?
Doctor,
Yes.
if we want to draw z, it will be like exponential function.
Yes, but only on the positive side. Yes, yes, it will be an exponential function.
Okay.
The amplitude is 1 over 5, okay, and it will be a growing exponential. It will be increasing. All right, any other question?
Doctor, what about the -1 inside the brackets?
You tell me what happened to that minus 1.
No, okay, I see.
Yeah, because there is a minus 5 outside, right? So that minus
Yes,
5
it
and
will
that
become
minus 5.
positive.
Yeah, yeah, exactly. Exactly.
Doctor,
Go ahead.
why integration from 0 to infinity, not to tau?
Okay. All right. Now, if you look here, uh, originally the integration is from minus infinity to plus infinity, right? And you see there is a u of tau here, right? So u of tau means that tau cannot be negative, right? Tau has to be 0 or any other positive value, right? Yeah. Are you following me?
Yeah, yes.
Okay. So that's why the lower limit is 0 here. Okay. Now for the upper limit, we don't have any other thing here that restricts us. We can have any value of tau, right? Because in the previous question we had this u of t minus tau. So because of that, last time we said that it should be, the upper limit should be t, because if tau becomes more than t, this becomes negative and this whole thing becomes 0. But right now we don't have this u of t minus tau here, right? So this means that we can have any value for the upper limit. So any value means we can have infinity. That's the maximum value that we can have, right? That's why it is 0 to infinity. Is it clear?
Yes, yes.
Right? Any other question? Or shall I give you questions to solve? Okay. All right. Now let's go to the slides. Yeah. Now here you see this question number 16. Yeah. Question number 16, x of t is e to the power minus alpha t u of t, and h of t is e to the power minus beta t u of t. Now you do the convolution of x and h. Okay. I will, if you want the formula, let me write it somewhere here. All right, I'll give you a few minutes to solve this problem, okay? Problem 16. And once you finish, you can either take a screenshot of your solution and send me a link. You can upload it to some website, send me a link, or you can send it by email to me, and then I will check if it is correct or not. Okay. So I'll give you a few minutes to solve it. If there is any question, you can always ask. Yes, how is it going? Is anybody working on the problem?
Doctor,
Yes.
I sent it to email.
Oh, you send me?
Yes,
Okay.
but I don't know if the solution is true or I made some
Well,
mistake.
that don't worry about the solution. I mean, I just want you to give it a try, even if it is wrong.
Okay.
So, where did you send it by email, right?
Yes.
Okay, okay, let me check it. Yeah, I saw it. You made a little mistake. Although, when you were solving the other problem 15, when I asked you what is y of t minus tau, so you said it should be e to the power 3, and then in brackets you should have t minus tau. But when you solved this problem 16, you forgot the bracket, and because of that, your answer is not correct. But the attempt was okay. Okay.
Okay, but I made it, doctor. I not put the bracket, but I made it without the brackets.
Yeah, but the thing is that it was supposed to be beta into t minus tau. So you said beta into t, but you did not multiply the tau with the beta.
Oh, I just write tau without putting.
Yes,
Okay.
yes, exactly.
This make all the solution wrong.
Well, the method is correct, but yes, the answer is wrong.
Okay.
All right. So,
Doctor, I'm not sure what to do with alpha and beta.
yeah,
I
okay, no problem. At least you give it a try. So now let me show it to you how should we do it. All right. So the question is this: okay, x of t is equal to e to the power minus alpha t u of t, and h of t is equal to e to the power minus beta t u of t. Okay. So first of all, we write the formula. So the formula is that y of t is given by integral minus infinity to plus infinity x of tau into h of t minus tau d tau. Now we know that x of tau is going to be e to the power minus alpha tau. Just replace t by tau, u of tau, and h of t minus tau will be wherever you see t, change it to t minus tau. So it is e to the power minus beta. Brackets are very important. If you don't put the brackets, your solution will be wrong. And u of t minus tau d tau. Then this is going to be equal to integral. All right, now what should be the lower limit?
0.
zero.
Okay, all right. Now, when I ask about the upper limit, someone other than you too should answer. Asil and
Oh,
Abdurrahman will not answer, someone else should answer. What should be the upper limit? Because I know you guys know it.
Infinity, doctor.
Infinity. Why?
Because it's a unit step, so the limits are from 0 to infinity.
So that means if you are saying infinity, so it means that this tau can be greater than t, right? If you put infinity, then tau can be more than t, right? Which will make this guy negative. And when this guy becomes negative, this whole thing becomes 0. So how can you have infinity?
Okay.
Anybody else? We did it several times. I don't know if are others there, or they are sleeping, or they just turned it on and went away. Hashim, are you there? Hashim al-Sharif. Okay, this explains everything. Osman,
Yes, Doctor, I'm here.
okay, you are awake. Muhammad al-Zahrani,
Yes, doctor.
okay. Abdul Ilah,
Yes, Doctor.
okay. So what should be the upper limit?
T, Doctor?
Yes, exactly. It should be t. Tau cannot be more than t, because if tau becomes greater than t, this t minus tau becomes negative, and u of t minus tau becomes 0. So the upper limit is supposed to be t e to the power minus alpha tau e to the power minus beta t plus beta tau d tau. Okay, then this is equal to 0 to t e to the power minus alpha tau e to the power minus uh, minus beta t.
I have a question here, doctor.
Go ahead, go ahead.
I think you do mistake here. I think it's beta t minus beta tau.
Are you sure?
Oh, no, no, no. Yes, because when I solve it, I forgot to put minus beta.
Yeah, yeah. Okay. All right, then we can see that this guy does not depend upon tau. So I can take this guy outside, right?
Yes.
E to the power minus beta t equals 0 to t e to the power minus alpha tau e to the power beta tau d tau. Okay, then this is equal to e to the power minus beta t 0 to t e to the power. Okay, now we can take tau common, right? So it is tau into minus alpha plus beta d tau. Now you know what is alpha and beta. Alpha and beta are constants, some numbers. Okay, so it's like a constant. Okay, so what should be the integral of this guy? What is the integral of this guy?
The value of minus alpha plus beta divided by
Correct.
tau.
Divided by
Minus alpha plus
exactly,
beta.
exactly. Yes, yes. So it should be e to the power tau minus alpha plus beta divided by alpha plus beta. The limits are 0 to t. Okay, and then this is equal to e to the power minus beta t divided by minus alpha plus beta, and inside, in place of tau, whenever you apply the limits, this t will be put in place of tau. Okay, and this 0 also will be placed in place of tau. Okay, so it's going to be e to the power let's write it like this: beta minus alpha into t, the upper limit, minus, when you put the lower limit as 0, it becomes 1. Right? And if you like, you can further simplify it. So when you multiply e minus beta t with the whole thing, it becomes e to the power minus beta t into e to the power beta t into e to the power minus alpha t minus e to the power minus. Divided by minus alpha plus beta, or this becomes e to the power minus alpha t minus e to the power minus beta t divided by beta minus alpha into u of t. Now tell me if there is anything which is unclear, or if there is any question.
I have a question, Doctor.
Sure, go ahead.
Go up the page. Yes, here. Why you take tau like a common, and why you don't multiply it?
No, I did not take tau common. I took t common. There are two variables. One is t and one is tau, right? So this guy, which I took common, this is t, and this is tau. This is
No, I
tau.
mean down. The next step.
Okay, even then, even here, this is t, and this is tau. This is tau.
Yes, I mean when you combine two exponential function, why you does not multiply it and just add the power? Why you take a common tau?
Oh, okay. This is what we did. Let me show it to you. E to the power minus alpha tau into e to the power beta tau. This is equal to e to the power. Now, when you multiply these two, base are same. What happens to the power? How do you
Uh,
multiply them?
when you add the power,
Well, this guy Zahrani, Sada Zahrani, turn off your mic. Turn off your mic. Yeah. Okay. So when you multiply this, what happens to the powers?
we add the power.
We add the powers, and that's what I did. So it's going to be minus alpha tau plus beta tau, right?
Yes.
Okay, and then I can take tau common, and it becomes minus alpha plus beta. And I took tau common because tau is the variable of integration. Now it clearly shows me that your variable of integration is multiplied by a constant. So it was easy for me to take the differential when I put at the bottom the differential of tau into minus alpha plus beta.
Okay, so you do this step just for simplification.
Yes, exactly.
Okay.
Otherwise, what's going to happen if you don't do this? You will think that we have one variable here, one expression here, and one expression here, and you will try to do two integrations, and things will become very complex then.
Okay.
Got it?
Yes.
Any other question?
Doctor,
Yes, go ahead.
do you have to put unit of tau at the end?
U of t you are talking about.
Units of t.
Yeah, yeah. Why? Because of this guy. The integration is from 0 to t, right? and there is no negative value which is allowed for tau. Since it is only allowing positive values, so that's why we have to have a u of t at the end to tell that it is only for positive values of t.
Okay, but why the upper limit is t, doctor? Why isn't infinity? Because we had unit step before, and it says the limits are from 0 to infinity. So that's why I'm
Okay,
confused.
okay. The thing is that the lower limit is decided from here, right? Because u of tau tells us that you cannot have a negative tau, right?
Right.
Okay, so that gives us the lower limit, which is 0. We cannot have negative values. The upper limit, that is decided by this guy, because t minus tau has to be greater than or equal to 0. Because if t minus tau is negative, then u of negative number is going to be 0. So that means minus tau is greater than or equal to minus t, okay, or in other words, tau is less than or equal to t. So this decides the upper limit. In the previous question, we did not have this. Since we did not have it, so there was no upper limit for the tau. But here, since we have it, so we have to have t as the upper limit.
Oh,
Is it clear
okay.
now?
Yeah, it's okay.
Doctor,
Go ahead.
go down, please.
More.
Yeah, there. Why we put minus a power minus beta t?
Which step are you talking about? This one,
No, no. Go
this
down.
one,
No,
this one,
no.
this one?
Yeah.
Okay. Okay, in this one, what is your question?
Why we put minus a power minus beta t?
Oh, okay. Okay, if you look here, this guy is multiplying this whole thing, right?
Yes.
Okay, so now when you multiply this e to the power minus beta t, so first you have to multiply this e minus beta t with this one, and then you have to multiply this with this one, right? So when I multiply this with this one, the first one, it is e minus beta t into e to the power beta minus alpha t, right? This is the
Yeah.
first term. Minus, then e minus beta t multiplies with this one, okay? So e to the power minus beta t, right? And
Yes.
then this e minus beta t remains as is. Then this, the second guy becomes e minus beta t into e to the power minus alpha t minus e to the power minus beta t, right? And these two together, that becomes 1, because this is e to the power minus beta t plus beta t, right? So this becomes e to the power 0. So that's why it is 1. So e to the power 0 into e to the power minus alpha t minus e to the power minus beta t. So this guy becomes 1. So you are left with e to the power minus alpha t minus e to the power minus beta t, right? Which is what we got over here, right? Is it clear?
Yes. Yes.
All right. Any other question?
Doctor,
Go ahead.
if you go at the very start, why did we slightly come on? Yes. Why did we replace e power of minus alpha with tau instead of t? It's tau in the integral and the formula.
You're talking about this tau.
Yes.
Okay. So x of t is given, which is this. right?
Mm.
And I want here x of tau. So wherever you see t, change it to tau. That's why I change this to tau and change this to tau.
Okay, it's tau.
Yeah.
I solved it as t.
No, 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 this is tau. This is very important. This tau and t, if you mix them up, then, you are done.
Yes.
Doctor,
Go ahead.
in the slide they write solve the problem two times. One time when a not equal beta, and the second
Mhm.
time with beta equal alpha. What does this mean?
Yes, yes, we will do that. First we finish, let's finish this, and then now we will do that.
Okay.
Yes, any other question before we move to the next problem? All right. So now let's go back to the same question. Okay. So here you can see that the question was x is e to the power minus alpha t u of t, and h was e to the power minus beta t u of t. If you look in the slide, okay, in the slide it says slide clearly says that you do it two times. Once with alpha not equal to beta, which is what we just did, okay? And the second time, assume that both alpha and beta are the same. Okay, so now you give it a try. Assume that both alpha and beta are the same and do this thing again. So in other words, either you can say, let me do it.
It will become both alpha or both beta.
Exactly, exactly. That's what I wanted to show, but you said it. Yeah, exactly. So basically, what we are saying is that uh, either you do this way, x of t is this, and you can say that h of t is equal to e to the power minus alpha t u of t. So you can see that both are same. Either you do it this way or make both of them beta. Doesn't matter, right? You have the formula here. Uh, Give it a try, and I think this time you should be able to do it correctly. If you have any question, you can always ask. So I'll give you a few minutes to solve.
دكتور,
Yes.
can I take? I don't think I can, but can I take beta and a alpha as a common multiplier?
What do you mean common multiplier? It is in the power.
Yes, but like I can take them and put a bracket on the other factors.
Yes, yes, you can do that. Yes.
Mm,
If you can show me what you are doing, maybe then I can answer you. You can just send me over the email a picture of what you're doing. Maybe then I can explain it better. All right. Did anybody complete it or give it a try? Or,
Yes, I sent it to mail, doctor.
okay, you should have told me because I don't know. Somehow it's not giving me a beep to tell me that message has come.
I think I do a big mistake, but
That's all right. Don't worry about the mistake. Main thing is you should try. Okay? And then I will tell you what the mistake is. All right.
I
So alpha t minus tau. It's alpha t. Okay, you take it outside. Inside you have this. Oh, Asil, what is 1 minus 1?
I know it's zero, but
So
I
then,
don't know.
khalas, if it is 0, it is e to the power 0. E to the power 0 is 1.
Uh,
There is no need for integration so much and, putting the
Wallah,
limits and all that. Of
all,
course,
all of this will disappear.
of course, you tell me if 1 minus 1 is 0, e to the power 0 is a 1. Khalas.
Okay, so e to the power zero will come one, and all of this will go.
Yes, of course, there is still integration. Okay,
No, still integration, yes. T
but
minus
not
zero,
that. Yeah, it won't be like this. Yeah.
it will be the e minus alpha t multiplied by t.
No, no, no. Yeah, exactly. Exactly.
Okay, okay.
Well, mashallah, very good. Yes, I think someone else was saying. Abdurrahman, was you saying something? Were you saying something?
yes, I
Right?
I'm not sure how this plays. Alpha equals beta. I tried, but
Okay, no problem. No problem.
I'm
Let
not sure.
me let me show it to you. All right. So now what he's saying that the question is x of t is equal to e to the power, what was it, alpha t or minus alpha t? Minus alpha t. Minus alpha t u of t and y of t is the same as the value of x of t. So it is minus alpha t u of t, right? So now what we do is we put it in the formula. So y of t is equal
Oh, okay.
minus infinity to plus infinity. And since I need x of tau, so it's going to be e to the power minus alpha tau u of tau. Okay. And then h of t minus tau, so it's going to be e to the power minus alpha brackets t minus tau u of t minus tau deta. Okay. So then this is equal to, again, the limits are the same from 0 to t. So it's 0 to t e to the power minus alpha tau, and the second one is e to the power minus alpha t plus alpha tau deta. Then this is equal to integral 0 to t e to the power minus alpha tau. Now I can separate them because there is a t and there is a tau, and t does not depend upon tau, so we have to take this out. So to take it out, I have to separate these powers. All right. So this is equal to, you can see that this guy does not depend upon tau. So I can take this outside the integration sign. E to the power minus alpha t equals 0 to t e to the power minus alpha tau e to the power alpha tau d tau. This is equal to e to the power minus alpha t
Doctor,
integral. Yes, go ahead.
I think it makes sense if we take a common minus alpha and tau.
It's the same thing, basically this is what it is. E to the power minus alpha tau plus alpha tau. What is this? Minus alpha tau plus alpha tau.
Okay, but if we take a common,
Why are you going to take a common? It's like this. If you have e to the power minus a, okay, and plus a, what will you do?
uh, 0.
E
Zero.
to the power 0, right? And that's what it is. I mean, why do an extra step of taking common and then solving it? It's very clear that this is 0. So it is e to the power 0 eta. This is equal to e to the power minus alpha t integral 0 to t d tau. Now what is the integral of d tau?
1. No, tau.
Tau, exactly.
Oh,
Yes.
Yeah, I know students get confused with this. If you have dx and you want to take the integral of this, it is going to
X.
be x, not 1. Okay, so this is going to be e to the power minus alpha t, and the integral of d tau is tau, and the limits are from 0 to t. Then this is equal to e to the power minus alpha t, okay, and inside you have t minus 0. So this is equal to t into e to the power minus alpha t minus 0. This is equal to t e to the power minus alpha t. Since t is always going to be positive, so I'm going to put a u of t. All right, any question?
Uh, if it asks for example, t equal 5, just apply t equal 5 in the equation.
Yes, yes, exactly. For example, if we say example, since u of 5 is 1, so it's going to be 5 e to the power minus 5 alpha. Clear?
Okay.
All right, now let's move forward. Where is my mouse? Okay. All right. Now this is quite easy. The input x of t and the impulse response h of t of an LTI system are given by x of t is u of t and h of t is e to the power minus 3t ut. Find the output. So you can do that. I leave it for you to try yourself at home. Similarly, problem number 18, that also you can do yourself. Where is my cursor? Okay, here it is. All right, now some properties of convolution, just like we had these type of properties for the discrete time system, we have similar properties for the continuous time system. So 1, 2, and 3, the first three properties are exactly the same as you saw in the discrete time system. 4 and 5 are a little different. So you can see that if in number 4, look at number 4. Uh, Let me bring the laser pointer. So number 4, you can see there is f of t convolution with the impulse response, impulse, not impulse response, impulse, delta t. So when you do the convolution with delta t, you get back your original signal, okay, using this integration. So basically it is like 5 multiplied by 1 is 5. 1000 multiplied by 1 is 1000. So you can think of f of t as 5000 and delta t as 1. Okay. Property number 5, it says that if you convolve your signal with a shifted impulse, then your signal is also shifted by the same amount, right? You can see that delta was shifted by t naught, so your signal is also shifted by t naught. All right?
Doctor, I have a question.
Yes.
In properties 4, the tau should be inside the limit minus infinity and infinity.
Again, say your question again.
It's like when we do the integration for impulse,
Mm-hmm.
and we put f of t naught.
Mm-hmm.
So here minus tau. I'm sorry, tau. It's have to be inside the limit.
Yeah, actually, tau is your. Are you talking about property number 4 or 5?
4.
4. Okay, so here you see tau is the variable of integration. So this minus infinity to plus infinity is for this tau.
Yes, I know, but if we want to be the answer f of t, okay,
Mm-hmm.
should tau t minus tau we consider it as a tau node, and tau node must be inside the
No, no, there
limit.
is no tau naught here. There is no tau naught here. Oh, you are no, no, no. Don't confuse with this t minus t naught. This is different, and this is different. Here you see, here f of t is convolving with delta t. Here f of t is convolving with delta t minus t. So this is different than this. Now, when we are trying to convolve this from the formula, this t minus tau is coming. There is no t naught and there is no tau naught in this one, in number 4.
Okay.
Okay. Let me show it to you. It is like this. You know. Hold on, let me show it to you. So the property that we have is f of t convolution with the delta t, right? And when we do this convolution, we say that it turns out to be f of t, right? So for this one, you can think of it like this. Let's suppose I have, this is my uh, delta, okay? So this is, okay, let me first do the other one. That will make things easy. Okay, so this is t. So when you are convolving with this, and then we say that the answer is f of t minus t naught, right? So basically what it means that your delta is here at t naught, right? And your signal is, for example, like this, okay? This is f of t. So when you do the convolution of this guy, which is delta t minus t naught, with this f of t, then what's going to happen is that the whole f of t is going to shift to the right by t naught. So you get the same signal but shifted like this, for example. But if you convolve with t, okay, the signal remains the same. Because what is convolution? In convolution, if you look at the formula, it's like this: minus infinity to plus infinity, f of t delta t minus tau d tau, right? So this means that you shift your delta by tau, right? So, and what is tau? Tau is this whole thing because it is going from minus infinity to plus infinity. So you shift delta by one value and then multiply by f of t. Then you shift it again by one value and then you multiply by f of t. You keep on doing this for all these values from minus infinity to plus infinity, right?
Okay.
That gives you the f, because remember there is this relationship delta t, sorry, delta tau d tau minus infinity to plus infinity, this is equal to 1. Okay.
Yes.
All right, then let's move forward. All right, practice problem 19. Given the following signals, x of t is given, y of t is given, and z of t is given. And then he's asking you to evaluate the following operations. Okay, so basically, in some of these cases, you can use properties, right? For example, to look at this one, the first one, x of t convolution with y of t. So what's happening here is that this will be equal to, what is x of t? 2 delta of t. And what is y of t? 4 u of t. Okay. Now one way is that you do the whole integration and everything, okay, the formula and everything. Another method is that you can use the property, okay. So this 2 and this 4, these are constants, so I can multiply them, so it becomes 4 to the 8, okay. And then this delta t and u of t, so it's going to be like u of t convolution with delta t. And we know that if you convolve a signal with delta t, you get back the same signal. So it is. Did you get it?
Okay. But for yt, it's equal yt.
No, yt is for u of t.
Uh,
Yt is this. So this
okay.
guy for u of t came over
Yes.
here.
I mean, 4 multiplied by u of t, is it equal to u of t? Because u of t it's go from 0 to infinity.
Yeah, but this is for u of t, that which means that it is this. This is u of t, right? And the height is 1. Okay. But since he said it is for u of
Oh,
t,
yes, yes, I
so that
understand.
means this becomes 4.
Just the amplitude.
Just the amplitude, exactly.
No, it will be different, doctor. If, for example, if we multiply it signal by this signal, we will not multiply it by 1, we multiply it by 4.
Yeah, what I'm saying is that if you look at y of t, how y of t will look like, this signal is y of t, right? So y of t is going to look like this, go up and like this, multiplied by 4.
Yes, yes.
And now when you convolve it with the delta, it remains the same. Only it will be scaled by this 2 and this 4, which gives 8. All right.
Okay.
Similarly, you can do x of t convolution with z of t. Okay, same thing will happen because x of t has delta t and z of t is this function. So when you convolve with delta t, you get back the same signal. Y and z, this you have to do, right? Y and z, there is no delta, so you have to do actual convolution using the formula.
Mm.
This d, you can use the property that it is actually y of t convolution with y of t, right? Plus
Z of t.
y of t convolution with z of t, right? Now this y convolution z, this you already did here, part C. So you have it. You only have to do this and then add it with this.
Okay,
All right?
why we don't multiply y of t? I'm sorry, why we don't add y of t plus z of t?
No, how can you add? This you want to add? Yeah, doesn't matter. You add them and then do the convolution. It will give you the same answer. You can do that as well. Both are correct.
Okay.
Actually, it will turn out to be the same thing. The way when you put y here, okay, and you put z here, it will be 4 u of t plus e to the minus 2t u of t. And then they are convolving with this. So you will have to do two convolutions. Automatically, it will become like that. Okay.
Okay.
All right, so this is for you. Next one. Yeah, this is very easy. Write the expression for y of t equal to x of t convolution with delta t minus 2. And oh, so this is going to be uh, like, for example, this one. Remember that the property that we are using here is going to be this one. If you remember the property. F of t convolution with delta t minus t naught. It gives you the same function but shifted by the same amount, right? So here as well, for example, here the function is x of t. So this means that x of t convolution with delta t minus 2 should give you back x of t minus 2, right?
Yes.
And x of t minus 2 is what? Wherever you see t, change it to t minus 2. This way, you have to do part B and C as well. This is the answer. Okay?
Okay.
Okay. This also is very simple. The impulse response of a low-pass filter is h of t equal to e-power minus t u of t. So he gave you h. Okay. Now he's saying determine its step response. That is the output when the input is a unit step. So whenever we are trying to find the output, let's take this example. You have a system whose impulse response is h of t, and here you have input x of t. When you do the convolution, the output is going to be y of t, which is actually the convolution of x of t and h of t, right? So in this problem, he gave you h of t. He said that h of t is e to the power minus t u of t, right? Did he give you x of t?
No.
Because he's asking us to find y of t. So to find y of t, I should have x
X
of
of
t.
t.
He gave you x of t. Where? He gave it here. Because when we say impulse response, what does it mean? The response of the system when the input is impulse. Similarly, when we say step response, it means the output of the system when the input is
Unit step.
unit step. Exactly. Similarly, when we say sinusoidal response, right? That means the output of the system when the input is a sinusoidal signal. So that means for this example, x of t is actually u of t, right? So we know x, which is u of t. We know h, which is e to the power minus t u of t. So I can find out y of t, right? So y of t will be u of t convolution with e to the power minus t u. All right. You have the formula. You can always apply the formula and find the answer. Clear?
Okay.
Okay. Any question? All right. That completes chapter number 2. Okay. Uh, let's take a break, and after the break, we'll start, inshallah, chapter number 3. Okay. Let's take a break of 10 minutes, inshallah. All right, do you hear me?
Yes.
Yes.
Okay. All right, so we're going to start a new chapter, which is Fourier series of periodic signals. You know what is a periodic signal, right? A signal that repeats itself after a specific interval of time is a periodic signal. In Fourier series, you must have done it in your math courses, but here we'll talk about Fourier series more in terms of signals and how do we apply it over the signals. Okay. Now, before we go into Fourier series, let's first look at what happens when you add several sine waves. Okay, so let me show you a MATLAB program. Okay, all right. Here you see two sine waves. Okay, one has one cycle, and the other sine wave, the orange one, has three cycles. Okay. Now, when you add these two signals, what's going to happen is that you're going to get this signal. Okay. Now, let's suppose I add one more sine wave to the above two sine waves. So, which means that, oh, it's plotting it in. I'll have to keep moving it here. Okay. So now I have three sine waves. The blue one has one cycle, orange one has three cycles, and the yellow one has five cycles. When I add these three, this is what I get. Okay. Similarly, if I add one more sine wave, that is, I'm going to add four sine waves, okay, and I add them, this is what I get. Okay, and as I keep on adding the sine waves, okay, you can see what is happening to the signal at the bottom, right? What do you think? What's happening to the signal at the bottom as we keep on adding sine waves? What are we getting at the bottom?
It will equal 1 somehow, and
How about the shape of the waveform?
It will stay there further and further.
See, as I keep adding sine waves, you are getting something which is close to a square wave, right?
Yes.
And the more sine waves you add, the more the shape of the waveform is a square wave, right? See here, this ripple is decreasing, right? It's becoming straight line as we add more sine waves. And ideally speaking, if you add infinite sine waves, it's going to be a perfect square wave, right? See here. So basically, what we are telling is that the more sine waves you add, the more the shape of the waveform is going to become like a square. Okay. So what Fourier says is, let me now go back to the slides. So sinusoidal waves are the simplest possible signals. Other signal shapes can be made using only sinusoidal signal. This is what Fourier series is, that you can construct any signal in this world by adding properly chosen sinusoidal waves, okay, of proper amplitude and proper frequency. Here, the example that I gave you, that was of constructing a square wave. So if you add sine waves with odd number of cycles, okay, with certain amplitudes, you can make a square. Okay, this is what I just showed you. Okay, so using Fourier analysis, any signal can be decomposed into sine waves having proper amplitudes, phases, and frequencies. So whenever you take a signal and we say that, okay, this signal has a frequency of 20 hertz, what does it mean? 20 hertz means that it is making 20 cycles in 1 second. Okay. Now, if someone says that this signal has three frequencies, 10 hertz, 20 hertz, and 30 hertz, what does it mean? It means this signal has three sinusoidal waves, one having 10 cycles per second, one having 20 cycles per second, and one having 30 cycles per second. When you add the three, you get the signal that you have. So is this clear before I move forward? Am I alone in the room or there is somebody? Somebody.
Yes, it's clear.
It's clear? Okay.
It's clear.
Asil, is it clear?
Is it clear? But I want to ask you a question.
Yeah, go ahead.
Why in the first line they said sinusoidal is the simplest possible signal?
Yeah, because by simplest we mean that you cannot break it into further signals. Any other signals, if you want to make, you will have to add several sine waves to make a new signal. But sinusoidal wave, this is the fundamental signal.
We cannot break it into sine and cosine.
No, this sine itself is yani, it is a sine signal. It itself is a sinusoidal signal. You want to break it again into sine?
Sinusoidal. This means it's sine and cosine.
Yeah, yeah, sine or cosine, because cosine is the same as sine with just phase shift.
Okay.
All right, is it clear now?
Okay.
All right. So now the question is that why we are talking about Fourier. Okay. We are talking about Fourier because it has several applications. For example, in MP3 compression, okay, the basic idea behind that is Fourier analysis. So what happens is that you take a sound signal, you expand its Fourier series. Okay, most likely it's going to be an infinite series, but let's suppose you take first few terms. The thing is that when you take first few terms, it is enough to reproduce the original sound. Rest of the terms, you can ignore them because they add so little that your ear, a human ear, cannot tell the difference. Okay, so you save the first few terms and you discard the remaining, and that takes much less memory. Same idea is there in JPEG compression. Okay? And same idea is there when you want to remove noise and unwanted signals from audio and images and videos. If you know the frequency of noise, you can filter that noise signal from your signal. Uh, and you can stop that signal of that frequency. Okay, and it's used a lot in image processing as well. Okay, to add information to the signal or to remove some information from the signal and so on. So if your signal is a periodic signal, uh, we have Fourier series for that type of signal. If the signal is an aperiodic signal, or in other words, it's a non-periodic signal, then what we use is called Fourier transform. Now let's look at the concepts of time domain and frequency domain. Okay, time domain is a time domain plot is an amplitude versus time plot. It is shows amplitude variations of a signal with respect to time. This is what we normally have. Uh, Let me show it to you as an example. So normally when we plot any signal, we plot it like this. Let's suppose I'm plotting a sine. Okay. Now tell me, what is on the x-axis?
Time.
Time, exactly. So on the x-axis we have time. And on the y-axis I have the amplitude of the signal. Right? So this is called time domain plot. Right? Okay. Then there is another plot which is called a frequency domain plot. Okay. So what is the difference? Frequency domain plot is an amplitude versus frequency plot. That is, it shows which frequencies and of what amplitude are present in your signal. So for example, if this is your signal, and let's suppose that this time is 0.5 seconds. Okay, so now let me bring the slide as well. Okay, so the frequency now, if you look at this signal, the time domain, what is the frequency of this signal? How many cycles it is making in 1 second?
0.5.
0.5 second is the time period, not the frequency. This 0.5 second, this is the time period.
1 over 0.5.
Yes, which is?
Okay, just 1 minute.
Yeah, you don't need anything for this. This is 2. 1 over 0.5 is 2. So it is making 2 cycles per second. Or in other words, the frequency of this signal is 2 hertz, right? If I want to plot this using a frequency domain plot, then on the x-axis I will have frequency, and on the y-axis I will have amplitude, right? So 2 means that if this is 0, let's suppose this is 1 and this is 2. So you will have, so this is frequency domain plot. So what is this plot showing you? It is showing you which frequencies and of what amplitude are present in your signal, right? So on the x-axis you have frequency, and on the y-axis you have the amplitude. So you can see that there is only one frequency of 2 hertz present in your signal. Is it clear? Any question?
Okay, doctor.
Anybody else? Abdul Rahman, is it clear?
Is it the amplitude, the second
Mm.
graph is continuous and the no, I mean the first graph is continuous and the second is discrete, or not like that?
Yeah, okay, this is a very good observation. The thing is that if your signal is a periodic signal, okay, then the frequency domain plot will be discrete, right? And if your signal is a non-periodic signal, then it will not be discrete, okay? So in this chapter, we are only talking about periodic signals. So the frequency domain plot will always be discrete, okay, in this case. So for
Oh,
example, if you have, let's take another example. Let's suppose you have two signals, like another one with, let's suppose something like this. Let's suppose it has 3 cycles. So you will have then another one here like this and here, because its amplitude is small. So in reality, if you want to see this signal in the time domain, it's going to be something like this.
okay.
Looks like I'm teaching only 2 students in this class. Okay. All right. What are the advantages of Fourier analysis? It tells you the frequency spectrum of a signal. What is the meaning of a spectrum? Spectrum is a plot that shows the various sinusoidal components that you have in your signal. I don't know if you saw, there is something called a spectrum analyzer. This spectrum analyzer is normally in the physics labs, okay, and which uh, it's a machine which shows you the different frequencies of your signal. So you give it the signal and it displays what frequencies are and of what amplitude are present in your signal. So that's called a spectrum analyzer, and a spectrum means frequency. Secondly, frequency domain representations are more convenient to analyze and process. There are many cases in which uh, working in the time domain becomes very tough. So we move to the frequency domain analysis. Okay. Uh, Another example is that in the frequency domain, linear systems are described by linear algebraic equations that can be easily solved. You know the algebraic equations like 2x1 plus 3x2 is equal to 0. This is an algebraic equation. Or x1 square minus 2x2 plus 3 equal to 5. This is an algebraic equation. In time domain, many times you have to solve a linear differential equation, and it is much difficult to solve a differential equation than to solve the algebraic equation. So in some cases, if you use Fourier and convert your signal to frequency domain, then it is easier to solve the system or to analyze the system. All right, we know that a signal is periodic if x of t is equal to x of t plus t. Okay. What does it mean when we say x of t plus t? It means that uh, even after t seconds, the signal is the same.
After the fundamental period.
Yeah, this exactly. We're talking about the fundamental period. Yes, yes. So when you want to show a Fourier series of our periodic signal, it's we express it as a sum of infinite functions, infinite series. Okay, you must have done it in math course. Any periodic function can be expressed as an infinite series consisting of sine or cosine functions. So for a periodic signal, the Fourier series representation is given by x of t is equal to k goes from minus infinity to plus infinity, a k e to the power j k omega naught. You must have done this in a different form. You must have done it in the form where you have sine and cosine. Here you have exponential, but it's the same thing. Why is it the same thing?
Because Euler identity.
Yes, very good. Because of Euler, you can always convert exponential into sine and cosine, right? So that's why it's the same. So here what it is, ak e to the power j k omega naught t. Okay. And what is omega naught? Omega naught is 2 pi over t or 2 pi f. If you put omega naught equal to 2 pi by t, this is what your equation becomes. X of t is equal to k, summation k goes from minus infinity to plus infinity, ak e to the power jk 2 pi by t to small t. Now what this equation is representing is that your signal, this is your signal, x of t. I can write my signal, whatever it is, square wave or rectangular wave, triangular wave, whatever it is. I can write the signal as a sum of all these terms. Because when you open it, it's going to be what? For example, if I start from 0, it's going to be a0 e to the power 0. This is one term. Plus a1 e to the power j 2 pi by t into t. Since it's a periodic signal, so I know capital T. 2 pi is a constant, right? And k I'm putting myself. First I put k equal to 0, then I put k equal to 1, k equal to 2, k equal to 3, and so on. Keep on going. So it's going to show me as a sum of so many terms. And all the terms are sinusoidal because you know e to the power j theta is cos theta plus j sine theta. So basically, it's going to be the summation of sine terms and cosine terms. Is this clear?
Yes, it is.
Slightly.
Hmm. Ask me where the problem? Where is the problem?
Maybe if we made it, if we visualize it.
Okay. Let me uh, let me expand it for a few terms. Maybe then it will become clear.
Okay.
So what we said that our signal x of t, it can be represented as a sum of, let's suppose I take k equal to 0 to 3, for example. Let's not take infinity because that might be giving you confusion. A k e to the power j k 2 pi over t into t, right? So this is my signal, okay, and it's a periodic signal. Since it's a periodic signal, so I know what is the value of t. T is, you know, some value. Okay, so then I can say that x of t is equal to a0, right, into e to the power 0, which is 1, so I don't write it, plus a1 e to the power j 2 pi by t into t plus
Mm.
a2 e to the power j 4 pi by t into t plus a3 e to the power j 6 pi by t into t. So that means my signal consists of four components. One is this, second is this, third is this,
Okay. Yes,
and
I
fourth is
remember
this.
this formula.
Yeah, from the math course, right?
Yes.
And if you look at this one, what are these A's? You know, these A0, A1, A2, A3. These are amplitudes of your sinusoidal waves. Okay? So
Mm.
if you look at A0, there is no exponential term here, which means that this is a constant, just a constant, like a DC, you know. You know the DC from circuit analysis? DC means how much is the
Yes.
frequency?
0.
Zero. Very good. So DC has a
Yeah.
frequency of zero, which means that this is a signal that has zero frequency. Then this is a signal whose frequency is this much, 2 pi by t. This is a signal whose frequency is 4 pi by t. And this is another signal whose frequency is 6 pi by t. So when I add these four sinusoidal signals, I get my signal back, x of t.
Okay. I see.
But
Right. So yeah, go ahead.
we study this for year in engineering mathematics. So there
Yes.
is four for year, one for odd, and it's have equation, I see now the equation. It's f of x equal summation from n1 to infinity, between brackets b of n sine n pi divided by L of x.
Yeah, actually, there are different forms of Fourier. It is written in several different forms. Okay, basically, all are same. It's a different way of looking at the problem, but the idea is the same. And they are all coming from here, from the exponential. This is the most general one, and in signal processing, this is the one which is used. This exponential mostly, right?
Okay.
So yeah, basically it's the same. So the problem reduces to finding a naught, a1, a2, a3. So whenever you have a signal x of t, and the question says that okay, expand its Fourier series or find its Fourier series component. So basically you have to find a naught, a1, a2, a3, and so on. All right. Now if you look at it in more detail, when k is equal to 0, this is a constant, right? We just saw it's going to be just a naught or a 0, right? And when k is plus 1 or minus 1, that means this is called fundamental frequency. Remember when we were talking about periodic signals, okay, we said that capital T is the fundamental time period. Similarly, 1 over capital T is going to be fundamental frequency. This is also called fundamental components or first harmonic component. If k is 2 or minus 2, then this is called second harmonic component. If k is plus 3 or minus 3, it is called third harmonic component, and so on. So in general, if k is plus n or minus n, it is called nth harmonic component. Clear? Any question?
Clear.
What's mean of harmonic this thing?
Yeah, these are called harmonics. Actually, when we have a frequency of anything, let's suppose the frequency is 10 hertz. Okay, so 20 hertz will be called as the second harmonic. 30 hertz will be called as a third harmonic. Okay? Harmonic is used for frequencies.
Okay. Like when some microprocessor, it's work on different frequencies. So we said this is harmonics.
Uh, Depends if it is a multiple of the basic frequency. If there is a fundamental frequency and there are multiples of those frequencies, then the multiples are called harmonics of the same frequency.
Okay.
All right, now let's take an example. Consider x of t with fundamental frequency 2 pi. That is expressed in this form. If you look here in the slide, this is the signal. So your signal is x of
Your
t.
voice is cutting.
Okay. Is there any problem with my internet?
Okay, it's back to good.
Yeah, okay. Yeah, sometimes it does. I know there is an issue with the internet. Okay. So x of t is this signal, right? So this x of t is my signal, and I know that its fundamental frequency is 2 pi, and it can be expressed like this, okay? And the components a naught, a1, a minus 1, a2, a minus 2, these are all known. These are given, okay? So if that is the case, then I can expand this, okay? I can open it and I can write it by putting these values here. Okay, so in other words, let me show it to you how to do it. All right, so the signal is x of t is given by sigma k goes from -3 to +3 ak e to the power j k 2 pi t. Okay, so when you expand it, it's going to be a minus 3, right? E to the power minus j 6 pi t, right? Plus a minus 2 e to the power minus j 4 pi t plus a minus 3 e to the power, not minus 3, minus 1, e to the power minus j 2 pi t. Okay, plus, yes, what should I write? Help me.
It would be
A of 0.
A of
A of
0,
0, exactly, right? Plus, then what should I write?
A of 1.
No, I
A1.
think no.
Why
Uh,
no?
Why don't write exponential function
With A naught?
with A of
it,
0? But
Yeah,
okay,
okay.
it will
It will
equal
be,
1. Okay.
yeah, it will be equal to 1. Yes, that's right.
yes.
So e to the power j 2 pi t, right? Plus, then a2 e to the power j 4 pi t, right? Plus a3 e to the power j 6 pi t, right? Is it clear until this point?
Yes.
Yes.
Okay. Now, the values of these are given. A minus 3, a minus 2, a minus 1, all of these are given. So let's put them. A minus 3 is 1 by 3. So 1 by 3 e to the power minus j 6 pi t. A minus 2 is 1 by 2, so it is 1 by 2 e to the power minus j 4 pi t. Plus a minus 1, which is given as 1 by 4 e to the power minus j 2 pi t, right? Plus a0, which is 1, plus a1, which is also 1 by 4 e to the power j 2 pi t, plus a2, which is 1 by 2 e to the power j 4 pi t, plus a3, which is 1 by 3 e to the power j 6 pi t. All right. Now tell me, is it clear?
Okay. It's clear.
So
Yes.
basically, don't forget that this is our signal x of t, that we are trying to see which frequency components are there, how this signal can be broken into sinusoidal waves. That's what we are trying to see. Okay. All right. Now this guy is alone. I can bring him here. 1 plus. Okay. Then you can see that there is 1 by 3 here, and there is 1 by 3 here. Well, no, not from here. Let's start from the smallest value. Yeah, let's take this one. So you have 1 by 4 here, and you have 1 by 4 here, right? So I can take 1 by 4 as common, and inside I will have e to the power j 2 pi t plus e to the power minus j 2 pi t, right? Is it clear? Are you with me?
Yes. Yes. Yes.
Okay. Okay. Then you can see that the other one is 1 by 2 is here, and 1 by 2 is here as well. So I can take 1 by 2 common, and inside it will be e to the power j 4 pi t, okay, plus e to the power minus j
Okay.
4 pi t, right? Now what is left is this guy, this 1 by 3 and this 1 by 3. So I can write it as plus 1 by 3 e to the power j 6 pi t, right, plus e to the power minus j 6 pi t bracket closed. Is it clear?
Yes,
Yes.
very clear.
Okay. Now, look at this. Can I do something with this guy?
Yes. It's
What can I do?
one
What? How?
because oh, it's not meant. Okay. It's,
It's not multiplying. Yes,
yes,
it's not
yes.
multiplying.
Uh,
Can you say the question again?
Yeah, my question was that can I do something with these two terms?
Which terms?
hmm.
This red one, the one that I underlined.
It will equal zero, or not like this,
No, why zero?
because it's the same power, but the second power is negative.
So basically, what you are saying is this: that if I have 2 to the power a plus 2 to the power minus a, so you are saying this is equal to 0? Or in other words, if I have 2 to the power 2 plus 2 to the power minus 2, is it equal to 0?
Not necessarily, I think.
It's
Have
equal
have have
to
answer, doctor.
2 power of 0.
Oh, who is this? There is somebody else. Let's hear. Who is this?
It's gonna be one over e to the power j 2 pi t.
So then, what shall I do with that?
This is it's simplifying. I don't know. I'm only simplifying the.
No, actually, okay. Let me remind you of a few formulas. Okay, if you remember, cosine theta is given by e to the power j theta plus e to the power minus j theta divided by 2, and sine theta is given by e to the power j theta minus e to the power minus j theta divided by 2j. Do you remember this relationship?
Okay.
Yes,
Yes.
it's Euler identity.
Yes, good. So I
So,
can do that.
but it's not divided by 2.
Yeah, it's not divided by 2. So what should I do then? I can
Oh,
say that's e to the power j theta plus e to the power minus j theta is equal to 2 cosine theta, right? And from here, e to the power j theta minus e to the power minus j theta is equal to 2j sine theta, right? So therefore, I can say that x of t is equal to 1 plus 1 by 4. Okay. Now theta in the first term is what it is.
2 pi. It's 2 pi.
Only 2 pi?
Uh, 2 pi t.
2 pi t. Exactly. So it's going to be 1 by 4 multiplied by 2 into cosine of 2 pi t. Right? Plus half, and you can do the same thing for this guy. In this one, it is again 2 cosine 4 pi t. Right? And then the last one, it is plus 1 by 3, okay, uh, into 2 cosine 6 pi t, right? So then I can say this is equal to 1 plus 1 by 2 cosine 2 pi t plus this 2 and this 2 cancels out, cosine 4 pi t, okay, plus 2 over 3 cosine of 6 pi t, right? Now you can see that we have converted our signal into a signal that is summation of 1, 1, 2, 3, and 4 sinusoidal signals, right? The frequency of the first signal is 0. The frequency of the second signal is 2 pi. The frequency of the third signal is 4 pi. And the frequency of the fourth signal is 6 pi. Okay. And now I can, but if I plot all these things, let me show you this full screen. Okay, and when I plot them, this is the signal with the zero frequency, right? The height is 1. This one is the signal with frequency of 2 pi, right? And amplitude is half. This is cosine 4 pi t. This is the signal with a frequency of 4 pi and a height of 1. And this is the third one with a frequency of 6 pi and the height is 2 by 3. So when you add this guy and this guy, this guy and this guy, you add all these four, you get this. This is your signal, x of t. So when you look at this signal, I mean, you cannot tell that it consists of 4 different frequencies. But when you use Fourier analysis, you can break it up into these 4 and you can tell, yeah, okay, there are 4 sinusoidal signals, each having such and such frequency. All right? Is it clear? Any
Okay.
question?
It's for cosine signal or for sinusoidal signal?
Okay, both are correct. Sinusoidal signal means it could be sine, it could be cosine.
Not both.
Not both. And well, I mean, sine is also called sinusoidal and cosine is also called sinusoidal signal. Cosine is only 90-degree shifted, but that is also a sinusoidal signal. So if this expression had cosine as well as sine, even then we will say it consists
Sinusoidal.
of 4 sinusoidal signals.
Okay. But what is the difference between sinusoidal and cosine?
They are same. I mean,
It's the same.
that's what I'm saying. Sinusoidal signal, whether it's a sine or cosine, both are called in general sinusoidal signals.
Okay. And this signal we can call it cosine signal, or we can call it sinusoidal signal.
Exactly. You can say that sinusoidal signal has 2 different types. One is sine, and one is cosine.
Okay.
All right. Any other question? All right. If there is no question, then I think we should stop because some of the students might have a lecture at 4. So I'm gonna stop now, and unless you have any question.
Yeah, Doctor, I have a question, please.
Sure. Go ahead.
The lecture before this, it was the practical signal and
Yes.
system.
Yes. Yes.
So I does not
You
present
did
in
not
it.
attend.
Yes.
Yeah.
Could I solve the lab and send it to you?
Okay. Talk to me privately. Okay. We'll talk later about it. Okay.
Okay.
Yeah. All right. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.
Doctor,
Go ahead.
I'm come late.
What's
My
your
name
name?
is Ahmed Abdeslam Al-Harbi. And in the Amali, I didn't come because in the hospital. I have paper here is proof in I'm in hospital in 10.
All right. What's your name?
Ahmed Abdeslam Al-Harbi.
Uh, tell me which number is this?
I think number 3 or 2.
number 3 or 2. Oh, Ahmad Abdul Salam. Okay.
أي
Okay.
دكتور
Yes, go ahead.
فهد المطرفي.